Jeremy, thank you so much for joining us today. First off, we've got a deep, thought-provoking question for you.
As usual. Mm-hmm.
If you could have your own, if you could have your own 5-star sushi chef, say that 5 times fast. Prepare meals every day for the rest of your life, but in order to do so, you would have to bathe daily in a vat of leopard moray eels and spotted Pacific octopi. Octopi?
Yeah.
During a feeding session. Would you do it?
What's the plural on octopus? Anybody know?
Octopi.
Yeah, I think it's octopi.
Really?
Yeah.
It is.
Okay, not octopuses. That sounds kind of weird.
No. Definitely don't
Yeah, that's
want
true.
to be in the...
Right. All right, so I'm guessing you would bathe with the octopi then.
I think that's a good guess. You're asking the rough questions. I would, and here's why. Octopuses are really smart. They problem solve.
Right.
But if you have a chef's knife, you go in there and you sort of get the octopus over the sushi master, and then the fish doesn't come fresher than that. And it's sort of a self-fulfilling cycle thing.
Okay, so he'd risk his life to have a 5-star sushi chef. There we go.
And while we're talking about interesting facts about Jeremy, really quickly, we want to get your plug in early. But before we do that, first, can you just tell us kind of who you are and what you do?
I'm Jeremy Fryer-Biggs, as I think we've established, and I work with a team of guys out of Somerville, Massachusetts, building hybrid manufacturing machines. And that basically means that it's like a 3D printer and like a milling machine in one. They're machines that can build parts out of plastic, build them up layer by layer, and machines that can also at the same time take a block of material like a wood or a metal and whittle them down, mill them down into whatever shape you want.
So this company is called Mebotics, correct? Is that right?
Yeah, it's open interpretation on how you pronounce it. I say Mebotics. Mebotics sounds like a curse word, like an old school English, Irish curse word, but...
Right. No, I mean, when I read it to Josh earlier, I said me buttocks, as in like the pirate saying my posterior.
We're actually surprisingly popular in the UK right now, and I don't know whether it's a name or whether they really like the product. That's true.
Me buttocks. Oh.
All right. So it's birthed from the frustration of machine tools that aren't just cutting the butter or the wood or the plastic or what have you. How did this begin, and what is the product that you have developed?
So the four of us came together at a makerspace called Artisans Asylum in Somerville, Massachusetts.
Yeah, we know that.
Part of the maker movement thing, the four of us all we loved making things. You know, we all had different backgrounds, and so we came together. We sort of vaguely knew each other. We all kind of respected each other's work. And Calvin came to us one day and said, hey, you know, I have this problem. I want to make stuff at home after I'm done here and after I'm done with work. And I just, you know, I don't have the tools to do the things I really want to do. And the tools I have, like a Dremel, make a lot of noise. And, you know, I'm bothering my girlfriend. I'm making a mess in the apartment. And on top of that, my neighbors are going nuts. What do we do about this? So we put our heads together, problem solved, and the original concept for this enclosed mill was born. And a couple of iterations later, we had the microfactory.
Wow. Now, now, what you're describing sounds pretty amazing. Can you? What could I, as an industrial designer, as I'm working in my process, how can I use this tool? Well, I mean, sounds like if it's doing all the different things you're saying, it's 3D printing, it's machining. It seems like that's a complicated tool to try to use.
It also slices empty Coke cans, in case you were curious.
and makes lattes, I'm sure.
Yeah,
that's nice.
Now, the way we kind of looked at it, the way we came at it, I did a bunch of consulting work for companies designing all kinds of cool things, bagel slicers, all kinds of weird things. And when I was doing that, I wanted a tool that would give me a range of abilities. I wanted to be able to print a plastic housing. I remember doing one project for a company that makes very cool optical devices, sort of eye testing devices called iNetra, and we would make these plastic cases for the device, and then we would build these circuit boards, and we'd have little mechanical parts, little gears and stuff inside, and we'd have to order something from McMaster and print something on somebody else's 3D printer and then borrow a mill to do the circuit. And it wasn't really ideal from an iteration standpoint. You want to build something, see how it's screwed up, do it again, and just do that quickly, rapidly. And you couldn't do that when you were borrowing somebody's tool here and trying to fit it into their schedule and ordering parts from McMaster and waiting 5 days for them to show up. And so I wanted to build a machine that would allow you to do all these aspects that really go into something you're making. You don't just print a part. You don't just mill something. It's multiple different steps. Have a machine in-house that I could do all of this at the same time, combine it, and make something really useful.
Okay, so you've got this machine that does everything. It's sitting on your desktop, right? It's about that size. It's a desktop-sized machine. What have you guys been able to make so far on the Microfactory?
The coolest thing we've done so far, and actually this is an open call. We have a list on our website. So anybody who wants to make a suggestion, the coolest suggestion, we'll make it for you and send it to you. But we've been, the cool thing I think we did was we helped a friend out. He was making these magnetic comic strips for a Kickstarter project he launched. And he needed a device to make, there are these really cool milled walnut backbones that have this inlaid magnetic, like white erase board on it. And you can you have the magnetic board, you drop in the pieces, and you can doodle a 3D part comic strip. And he needed a way to actually make the thing. He had sold it on Kickstarter, and he needed a way to produce it. And so we loaned him 2 microfactories, and he made these cool walnut backbones for his thing on the Microfactory.
Wow.
Now that's okay. So let's back up a second here. How does this thing work? I have here a model of a man-eating bunny rabbit. It's a very dangerous animal that I found in my basement and modeled in SolidWorks. Anyway, I want to make one of these things on your machine. How do I do that?
Great question. It depends on what you want the man-eating bunny rabbit to be made out of. I'm not building a man-eating bunny rabbit. I want it in metal because, the scariest bunny rabbit I can conceive of. So I'm making this thing. And it also depends. If you want the arms to have kung fu karate chop action, that's going to be a different model. But if I'm making this SolidWorks, I export it from SolidWorks as an STL file. Okay. I will use a free open source CAM program like a CamBam, and that will create a toolpath for the whole thing. You would put your block of aluminum into the machine and lock it down, and then you would hit start. I'll put a bit in, obviously, because you have to put a bit in the router, and you hit start, and the thing would layer by layer cut out your man-eating rabbit. If you wanted it like an action figure, you would break it into multiple parts in SolidWorks. You'd run CamBam on all of them, and then you would separately take all the pieces, and at the end, put them together.
Right. So, but here's my question. When you said that this thing can build up and cut away material, I'm thinking on the same model, right? So I'm thinking like it builds up it builds up my bunny rabbit in plastic and then machines out the details that I want to be really crisp. Is that not true? Can I not do that?
You can absolutely do that if you wanted to.
What?
Yes, seriously, it's pretty cool. You could print your bunny rabbit in plastic. There are certain combinations you can do. So you could print it in plastic. When you're done printing the thing up, or you could just have a tool change. You go halfway up, let's say. You put a bit in the chuck, and you can mill out, the parts you would want to mill, and then pull out another tool change, and then go back to printing. You can go back and forth. You can't really mill and then print into a milled part. You could sort of do that, but you can definitely print and then mill into a printed part.
Yeah, but there is still a tool change. But that is really cool. I mean, that really breaks down a lot of barriers. So the each individual component here, let's break that down a little bit. How does the 3D printing portion of it compare with other 3D printers out there as far as print resolution, print size, and then how does that correlate to the milling capability of it also?
Really good question. So we wanted to make this thing pretty precise for what it is. And so we're 32x microstepping on the motors, which means that we have a resolution positionally of about 1/10,000th of an inch. when a certain large printer company, I don't know whether we can say their name on air, but a certain large printer company, when they print, they're printing at 100 microns, which translates to about 4/1000 of an inch, a little under 4/1000 of an inch.
Right.
So we're positionally about 40 times better. With that said, the limiting factor on our machine from a printing standpoint is going to be the diameter of the extrusion nozzle. So we're FDMing like this other unnamed company. We're pushing plastic through, and the diameter of the hole in that nozzle is going to be much larger than the resolution positionally on the machine.
Right. Right.
So the hole diameter is about 0.35 millimeters, and then you're going to have a little squishing as you go up layer by layer. So it's going to be a little wider layer-wise, even with a little overlap, than 0.35 millimeters.
And how are you guys managing adhesion? Are you using good old blue tape, or do you have a heated build platform or anything like that?
We have a heated build platform. One of the really cool features, I think, of the machine, we said to ourselves, well, if you're going to do a machine that prints and mills, you need a surface that you can do both on. And particularly, if you have a printing surface, it's going to be out of aluminum or some metal, right, with cap on. And so if you have that set up, and let's say I switch to a milling function. I start to print, I switch to a mill, and I have to overshoot to get a hole. Because when you're boring on a mill, it's not a flat, it's not like an end mill. It's got that sort of rounded edge to it. So you have to overshoot when you're punching a hole if you're going all the way through, which means that you're going to dig into the surface. Well, if I have an aluminum surface and I've got that bit, I run a chance of blowing the bit if I'm just ramming it right through, right? If I'm doing a milling function, I've got this soft spoil board, which, I can overshoot, and I'll go into the spoil board, and it's no big deal because the spoil board doesn't cost any money, and it's not going to break the bit. But things that are good for spoil board materials, soft materials, tend not to conduct heat very well. So we have this really cool combined spoil board that we're going to make available that both conducts heat, like a heated printing surface, and allows you to mill through it.
That sounds amazing. Now, you developed this, as you said, at Artisans Asylum. We are definitely familiar with you guys. You do so much cool stuff over there. We've interviewed people from the Hexapod robot, for example, project. By the way, do you work on the Hexapod?
I watched the Hexapod be built. He is amazing. That whole process is pretty
Yeah, it's just mind-blowing stuff. But, it's got to be a pretty just amazing, frenetic, creative kind of environment. And I'm sure that has its advantages and disadvantages, or at least challenges as you're working. So tell me a way that working at Artisans Asylum or in a makerspace in general has worked really well for this project, and maybe also a way that it's been a challenge, or you've found ways of overcoming challenge, perhaps.
Right. Well, it is called the asylum for a reason. We're all bad. There's positive and negative to that. The positive is you're in a space with incredibly creative and self-motivated individuals. So you've got a question. You venture into an area that you can't solve, and there are people around you just turn to. You tap them on the shoulder and say, hey, what do I do here? And more often than not, they're going to have a good suggestion or be able to find somebody who can help you. So the ability to bounce ideas, collaborate, is amazing in a makerspace like the asylum. And also a lot of tools, which is pretty cool.
Yeah.
So on that note, in developing this in that space, can you sort of guide us through how it came about? Like, what sort of software you're using, how you prototyped? Did it take a lot of iterations? What were the struggles with that?
It's been a long process. We started February. We really began February of last year. So what is that? More than a year and a half.
Mm-hmm.
And it started as us modeling on SolidWorks. We had this idea, like I said, from Calvin to want to build this enclosed mill. We hadn't gotten to the printing part yet. So we started modeling in SolidWorks, and then using CanDAM the same way you use it on our machine, and borrowing a big table router from the asylum and just cutting sheets of MDF into rough forms and starting to piece them together and seeing this. So first came the chassis, then came the rails, and there were multiple iterations of rails, different materials, hardnesses, shapes, bearings on those rails changed, just trying things, trial and error, trying it, seeing it, oh, that doesn't work, let's change it, let's tweak it. a ton of trial and error on the rails and the chassis, and just building, changing, building. We ultimately started from scratch, built, and then tore down 5 versions of the machine. And it's kind of cool. At Artisans Asylum, we have them all lined up next to each other so you can sort of see the evolution, which is kind of awesome.
Right. And so I actually was wondering, how did you decide to go with SolidWorks? I mean, that's obviously not an open source maker kind of program. Do you guys have access to it because of your jobs or something? And then why did you choose to go with that tool and not, say, Fusion 360 or the Solid Edge monthly subscription, any of these ones that have tried to kind of reach out to the maker community in a more direct way?
Like I said, the Asylum's weird, and so we have it free at the Asylum.
Do you really?
Yeah, well, we paid for it, but, to the members on certain computers, it's available.
That's awesome.
Yeah, and that's half of it. The other half is the platform years because of my job, and I'm just comfortable with it.
Right, of course. And we also noticed that you are currently seeking crowdfunding on Kickstarter. Now, why did you choose to go with Kickstarter over, say, Indiegogo or some other crowdfunding platform, since there seems to be a new one every week now? So
right. Well, to my knowledge, there's sort of 3 hybrid machines in the marketplace, 3 major hybrid machines in the marketplace right now. And one of our competitors, that's Totem. Marco's a nice guy. We've talked to them. They're cool. They were doing Indiegogo. And so part of it was not trying to crowd the same platform.
Oh, gotcha. Okay.
Yeah, so part of it was just trying not to both be on Indiegogo, and part of it was that, we felt that Kickstarter has successfully launched a lot of 3D printers. Form 1 Labs comes to mind, a number of others, and it might be a good platform for this.
Absolutely. Have you ever tried running any non-conventional materials through there? Like people, there are people that do 3D printing with clay or with chocolate or whatever. And I can just think, if you printed a chocolate bunny and machined out some nice mechanical details, you might be onto something.
I love this question. And the answer is, the whole point of this machine was not to be a hybrid. I mean, it is a hybrid machine, and it is going to print and it's going to mill. But we wanted to make a Cartesian platform that you could buy and say, you know what, I'm not so interested in milling. I want to extrude cake batter. Or I want to print ravioli, or I want to turn this into some paint studio, like a CNC paint shop, or
right.
Whatever you wanted to do. We've got expansion slots on the gantry. The whole left wall comes out, and you can build your own module, whether it's a paint tank or whatever. Stick it on the side. It's all designed to be hacked, and so yes, I'd love to run chocolate. You probably wouldn't run it through the same boat and tubes you're doing plastic,
right?
But we have a lot of power in the heater, much more power than the competition, and we've run polycarb. You can run some other plastics. We've done PLA, we've done ABS, we've done polycarb. You can run some other plastics through there that you probably couldn't get away with on other machines.
Right. All right. So, Jeremy, thank you so much for being on the show with us today, Jeremy.
Thanks for having me, guys. This was really fun.
A production of EVD Media.